We've always thought the cheapest model means weaker compliance.
Actually, a router that swaps Mini for Pro on the fly keeps costs low and compliance high.
So a single workflow can serve both routine and high-risk queries.
Exactly. Real-time tiering lets you meet NIST standards without inflating token spend.
And, if you're building or managing or even just budgeting for contact center AI right now, you know exactly how heavily that assumption weighs on every single roadmap decision. Welcome to the deep dive.
Yeah, glad to be here to dig into this.
So our mission today is really to just tear down this compromise that's been holding enterprise architectures back. We're looking at a stack of incredibly revealing sources today: architectural blueprints, internal deployment briefs from Kanerika, and raw data from a massive telecom pilot.
Right, and they all point to this fundamental shift in how we handle large language models in production. Because, the standard belief is that you're forced to choose, right?
Exactly. You either deploy cheap, blindingly fast models and just kind of accept the anxiety of potential hallucinations and compliance breaches.
Yeah.
Or you lock yourself into the heavyweight, highly secure models that absolutely decimate your profit margins. But the documentation we're going through today, it just totally shatters that binary.
It really does. The mechanism making this possible is a dynamic model selection router
Yeah.
embedded directly into the workflow architecture. So it doesn't just default to one model.
Right.
It automatically evaluates the specific nature of the user's interaction and toggles between the GPT-5 mini model and the GPT-5 Pro model in milliseconds.
Which is wild when you think about the scale of it.
Yeah, so if a customer has a routine inquiry, say, asking for store hours or, a basic return policy, the router pushes that to the cost-optimized mini tier. But the second an interaction becomes compliance sensitive, it's instantly elevated to the Pro tier.
So they're getting the best of both worlds.
Exactly. By deploying this specific real-time tiering, operators are dropping their per interaction costs by roughly 42%.
Ouch.
And the crucial part is that they're achieving that cost reduction while fully preserving SLA-grade accuracy for the queries that carry actual regulatory risk.
Okay, let's unpack the mechanics of that a bit because, looking through the official vendor documentation, you really don't get the full picture of how this operates under the hood.
Definitely not.
To visualize this, I like to think of this dynamic router as a hospital triage system.
Well, that's a good way to look at it.
Right. So if you walk into an emergency room with a scraped knee, the triage nurse doesn't call down the chief of surgery. They send you to the physician's assistant.
Yeah, exactly.
That is our GPT-5 mini. It's highly efficient, it moves quickly, and it handles the bulk of the routine daily volume. But if you walk in complaining of chest pains, something carrying high systemic risk triage just bypasses the queue and instantly routes you to the specialist, which is GPT-5 Pro.
Right. The specialist steps in.
But I have a fundamental structural question here, because in a contact center, a customer doesn't neatly categorize their thoughts, right?
Oh, never. They're all over the place.
Exactly. They might start with a routine question about a bill, but in the exact same sentence, they just blurt out their social security number or their medical history or their account password.
No, happens all the time.
So how do you prevent that routine mini model from accidentally ingesting and leaking personally identifiable information, PII, before the router even has time to make a decision?
Yeah, that is the exact friction point that trips up most legacy architects. And it's where the undocumented reality of this architecture really shines, through a process called privacy by design tokenization.
Okay, what does that actually look like in practice?
Well, what platform engineering teams are actually doing here is hashing that PII at the edge of the network before the API ever even invokes the GPT-5 mini model.
Wait. I want to make sure I fully understand the sequence here. So the model itself never processes the raw text of the customer's data.
Correct. The edge architecture acts as an interceptor. It scans the incoming data stream, identifies the sensitive PII, like that social security number, and instantly swaps it out for a unique, mathematically generated token hash.
Oh, wow. So the LLM is just looking at gibberish, essentially.
Right. The language model only ever sees and processes the hash, not the underlying data. And this is a profound shift because it completely eliminates the need for downstream redaction.
Because historically, AI systems ingest everything, and then you have to run a secondary scrubbing process to clean the logs afterward.
Exactly. You're cleaning up the mess after the fact.
Yeah.
But by moving the hashing upstream to the edge, your audit log storage requirements just plummet. The briefs show a 65% reduction in audit log storage right out of the gate, purely because you aren't storing massive amounts of toxic, sensitive data.
That is, I mean, the downstream effects of that are incredible, especially when you look at European privacy laws.
Oh, absolutely.
The brief noted that GDPR incident response times the General Data Protection Regulation protocols, they're shrinking from an average of 48 hours down to just 12 hours.
Yeah, a massive drop.
And if I'm following the logic here, that happens because there is no central raw repository of AI logs to dig through and scrub. When a customer submits a right-to-be-forgotten data deletion request, you just, delete the key to the hash and the data is functionally gone?
That is the mechanism, yes.
Yeah.
You're scrubbing the data before the physician's assistant ever gets into the room. But there's another layer to this under-the-hood reality that fundamentally changes the agent experience, and that's the explainability hooks.
Okay, tell me about those.
Well, for years, we've debated the black box nature of AI, right? You put a prompt in, you get an answer out, and you have literally no idea how the model arrived at its conclusion.
Right, it's just magic or terrible guesswork.
Exactly. But this architecture tackles that by utilizing structured reason code JSON payloads. And JSON is just a lightweight data formatting standard that allows servers to talk to user interfaces. So instead of just spitting out a flat text answer to the human agent, the API explicitly exposes the top 3 reasoning steps for every single model response. And it feeds that directly into the agent screen.
Which gives the human in the loop actual context. I mean, you aren't just treating the customer service agent like a robot reading a script. You're showing them the underlying logic of why the AI believes this is the correct path.
Exactly.
It's fascinating to see the theory, but as architects, we need to know the actual blast radius of these mechanics when they hit production. So let's dig into the Kanerika deployment.
Yeah, this is a great case study.
They built what the documentation calls a bias to revenue pipeline, which is, that's a pretty bold claim.
It is bold, but they actually backed it up with structural evidence. What's fascinating here is that by running continuous audits against this dual-tier system, they established a direct causal link between compliance metrics and return on investment.
Okay, how so?
Well, the Kanerika data demonstrated that just a 1% reduction in flag bias incidents, situations where the model might use phrasing that alienated certain demographics that directly translated to a 0.4% lift in their Net Promoter Score, or NPS.
Wow, a direct correlation.
Yeah, and that NPS lift was not just a vanity metric. Because the AI was dynamically routing and carefully handling diverse phrasing and edge cases, it yielded a 28% overall boost in customer retention.
But we have to look closely at the failure modes here, too.
Oh, for sure.
Because if your infrastructure isn't scaled to handle this continuous auditing, the whole pipeline breaks down. In that exact bias audit scenario, the briefs warn about audit pipeline latency.
Right, the SLA window.
Yeah, the Standard Service Level Agreement, or SLA, for these systems is a 4-hour turnaround. If your compute scaling is too weak and those bias drift alerts get delayed past that 4-hour window, the bias phrasing persists in live customer interactions.
Which is incredibly dangerous.
The documentation highlighted one specific instance where latency let a subtle tone bias slip through the cracks, and it actually caused a 15% NPS drop among non-native speakers almost overnight. So the theory of a dynamic router is elegant, but the underlying compute plumbing just has to keep up with the data volume.
The plumbing dictates everything.
Yeah.
And we see a remarkably similar dynamic with those JSON explainability hooks we discussed earlier.
Right, the reason codes.
Yeah. There was a pilot with a major telecom provider that tried leveraging those reason codes. And when the system functioned properly, the results were stellar. It reduced their call escalation rates by 22%.
That's huge for a telecom.
Massive.
Yeah.
Because the human agents understood the context of the AI's recommendations. They spent less time confused, which cut their average handling time and actually freed them up for higher value cross-selling.
Because it's like giving the human agent the AI's scratch pad. They can see the math, so they trust the recommendation.
They do. But here is the trap hidden in the architecture. The payload limit. If a customer has a highly complex issue, and the request payloads, the transcripts and account histories, if they exceed the 200,000 token limit, the system doesn't throw a massive flashing error message.
So what does it do?
To save space and process the request, it just silently drops that reason code metadata field entirely. It degrades gracefully.
A silent failure is terrifying from an operations standpoint. The agent is suddenly flying blind, and they have no idea why. The answer just appears in the UI, but the scratch pad has just vanished.
And the data reflects how damaging that is. In that telecom pilot, whenever those payloads truncated and dropped the reason codes, they saw a 22% spike in average handling time.
Yikes.
Yeah, agents were forced to manually escalate the call to a manager because they couldn't figure out why the system was recommending a specific, potentially costly action, and they just didn't want to take the risk.
And you wouldn't even know the system was broken until you reviewed the handle time metrics at the end of the week and wondered why efficiency just fell off a cliff.
Exactly.
So we've seen the revenue impacts and the efficiency traps. But there is a third dimension in these sources that changes the enterprise risk profile entirely, and that's risk avoidance and misclassification penalties.
This is where the financial stakes really peak. For Fortune 500 contact centers, deploying these dynamic routers with audit trails that align with the NIST AI risk management framework, which is, the gold standard for cybersecurity and AI governance, that yields an average of $1.2 million in annual risk avoidance savings.
Right, because you're drastically lowering the likelihood of regulatory enforcement because you have the mathematical proof of how decisions are being made.
Precisely.
But that assumes the router never makes a mistake. This raises an important question. What happens when the triage system fails?
Yeah, that's the scary part.
Let's say a customer asks about the early termination terms of a financial loan. That is a highly sensitive, regulated query. If the router misclassifies that and mistakenly sends it to the lightweight GP5 Mini instead of the rigorous GP5 Pro, what is the actual fallout?
That is the ultimate nightmare scenario for compliance officers. I mean, the Mini model is highly capable, but it is not tuned for rigorous regulatory guardrails.
Right.
If it catches that query, it might hallucinate a legal disclaimer that doesn't exist, or it might simply omit mandatory regulatory language. And if that unverified response goes out to a customer, you're no longer dealing with a bad NPS score.
You're dealing with lawyers.
Exactly. You could trigger a GDPR breach audit, which, depending on the severity, can carry fines upwards of $3 million. And we also have to factor in the edge hashing privacy mechanism we covered earlier.
The tokenization.
Yeah. There's a deeply technical risk there called a hash collision.
Let me see if I can frame a hash collision clearly for you. Imagine a massive coat check at a theater, right? Edge hashing is like giving every coat a unique ticket number. But if the algorithm generating those tickets isn't mathematically complex enough, it might accidentally print the exact same ticket number for two completely different codes.
That is a perfect analogy. If the hashing algorithm lacks cryptographic depth, it maps two distinct customers to the exact same token hash.
So to the AI model, customer A and customer B suddenly look like the exact same person.
Exactly. And then the AI might leak cross-customer data, offering highly personalized financial recommendations to customer A based entirely on the secure private profile of customer B.
Oh man, that is a catastrophic erosion of trust.
Total disaster.
True. Okay, so if you are listening to this and you're tasked with building this architecture tomorrow without stepping into these failure modes, where does the first shovel hit the dirt? Because we need to translate this from theory into a practical four-step framework based on the enterprise deployments in these briefs. Is it primarily an engineering problem at step one?
Surprisingly, no. Step one is entirely about governance.
Yeah.
You have to define the risk tier matrix.
Governance first, okay.
Yeah. Your AI Governance Council, which really must be led by your compliance team but remain accountable to your customer experience strategy team, they have to sit down and map your actual business intents into cost-benefit buckets.
They draw the line in the sand.
Exactly. They mandate that high-risk financial intents must go to GPT-5 Pro with a full, immutable audit trail, while routine password resets can be safely routed to GPT-5 Mini with a lightweight audit.
And the sources are incredibly strict about decision rights here. Because if accountability is split evenly down the middle between compliance and CX strategy, you end up in a deadlock.
Oh yeah, the Kanerika brief really dug into that.
It did. It highlighted a scenario where a tone bias alert triggered during a pilot. Compliance immediately wanted to pause the rollout to investigate, while CX strategy wanted to keep it live to hit their quarterly handle time metrics.
Naturally.
And because neither had ultimate veto power, the resulting deadlock stalled the deployment for weeks. It cost the organization a projected $4 million in revenue uplifts. You just cannot have ambiguous ownership.
Which brings us to step two, engineering the routing rules. Once governance defines that risk tier matrix, platform engineering operating under the CTO actually builds the physical logic.
So they're the ones executing the mandate.
Right. They enforce the upstream edge hatching to prevent the PII leaks we discussed, and they establish a unified data contract. The router cannot make split-second decisions if it's being fed messy, unstructured data.
Makes sense. And that leads into step 3, which is implementing schema visibility. Now, this falls squarely on the API product team.
Yeah.
If you go back to our delivery driver analogy, the API team has to ensure the fragile package, the AI's reasoning, survives the journey. They design the explainability payload schema, so those JSON reason codes make it from the language model all the way to the UX designers and compliance dashboards.
Exactly. They're the ones who have to architect a workaround for that 200,000 token limit so the agents never lose their scratch pad.
Right, and then what's the final step?
Step 4 is continuous 10K rescaling. A static model is a decaying model.
Always.
So your data science operations team must run a continuous audit pipeline that rescales and evaluates the models every 10,000 interactions, regularly checking them against the NIST framework.
And if tone bias drift is flagged?
Then the model ops team has to retune the system within that critical 4-hour SLA to prevent the kind of retention drops we saw in the earlier case studies.
So when you look at an organization that actually executes those 4 steps, the systemic implications are massive. Let's talk about what fundamentally changes in a team's architecture.
Sure.
The first thing that jumps off the page is the sheer force of that edge hashing requirement. It breaks down legacy data silos. You can no longer have 5 different departments using 5 different data formats because your upstream systems are basically forced to adopt a single unified data contract to tokenize the information before it hits the AI.
Right.
It acts as a massive forcing function for enterprise data hygiene.
It does. And structurally, it changes the corporate hierarchy, too.
How so?
Well, those formal AI governance councils, they stop being, theoretical advisory boards that meet once a quarter to discuss ethics. They evolve into actual AI steering committees with real operational teeth and veto power.
Oh, that's a big shift.
Yeah, this dynamic forces senior leadership to dramatically raise their own AI literacy, which consequently accelerates the greenlighting of other advanced tools, like LLM-driven quality assurance.
That makes total sense, but there's also a hidden roadmap advantage here that I think a lot of standard vendor pitches completely ignore.
Yes, the dual-tier routing architecture creates what economists call a price elasticity buffer.
Right, because when your entire enterprise is locked into a single massive model for every single query, you are entirely at the mercy of the vendor's pricing changes.
Exactly. But when you implement a dynamic router that can instantly shift, say, 70 to 80% of your routine traffic to a much cheaper tier, you gain immense leverage.
You're not trapped.
No, you can negotiate much more favorable enterprise terms directly with OpenAI or other providers because you're no longer a captive audience to their most expensive compute tier. You gain financial flexibility without sacrificing a single degree of compliance coverage.
That is an architectural choice that actually gives the procurement team leverage during contract negotiations, which is really rare.
It is rare. And if we connect all these mechanics to the bigger picture, it leads to a rather controversial reframe of the entire contact center business model.
Okay, let's get into the controversial part.
Well, the traditional, deeply ingrained view is that maintaining full-stack auditability for every single GPT-5 interaction is a massive cost center. It's viewed as a heavy tax you pay just to keep the regulators off your back.
Well, sure, because storage costs, continuous compute auditing, edge hashing architecture, none of that is free. It adds up quickly.
It does add up. But the forward-thinking perspective we're seeing in these deployment briefs flips that narrative completely. Those systematic, NIST-aligned, perfectly auditable logs are actually creating a proprietary trust signal.
A trust signal?
Yeah, it's mathematical proof that your AI is safe, unbiased, and transparent. Forward-thinking contact center operators can package that transparency as a premium service tier.
Oh, wow.
You can go to the market and outprice your competitors, precisely because their AI decision-making is hidden behind an opaque, unexplainable black box, while yours is fully documented, instantly auditable, and resilient.
So you transform compliance from a defensive cost center into an offensive, revenue-generating competitive moat.
Exactly.
You aren't just selling operational efficiency, you are selling provable trust. And if you're listening to this right now and you want to understand how CRM and AI platforms actually work under the hood, exactly like we just broke down today, you need to subscribe to the CRM Position podcast.
Absolutely.
We don't read marketing brochures here. We strip away the vendor hype and break down the real, complex architectural shifts that are actually moving the needle in production. So hit subscribe to the CRM Position podcast right now to ensure you stay ahead of the structural shifts that matter.
And to make sure you're ahead of this specific shift, we have 3 concrete actions you should should execute this week. Action 1.
Hmm.
Audit your top 10 contact center intents.
Okay, step 1.
Right. Sit down with your operations team and explicitly categorize them into a GPT-5 mini routine routing bucket or a GPT-5 Pro compliance heavy bucket. You cannot build a router if you don't know your baseline.
Perfect. Action 2. Check your edge architecture today. You need to verify with your engineering team that your PII tokenization is happening upstream before model invocation. If your data flow relies on downstream redaction after the AI has already generated a response, your audit logs are carrying toxic risk and you're bleeding money on unnecessary storage.
Spot on in Action 3. Verify your API schemas. You must ensure your architecture can support the JSON reason codes without silently hitting that 200,000 token limit. Make sure your customer service agents are actually getting the context they need without the system silently dropping payloads during complex, long-running interactions.
Think back to that hospital triage analogy we explored earlier. If you walked into a hospital and the doctor made a life-altering decision, but the hospital administrators refused to show you the charts or explain the reasoning behind the treatment, you would turn around and walk out.
Yep, 100%.
So I want to leave you with this final question to reflect on. If your biggest competitor turned their NIST-aligned AI audit logs into a customer-facing trust dashboard tomorrow, proving exactly how and why they make every single decision, how much market share would your black box architecture lose?